Good afternoon, and thank you for coming for the afternoon. I want to thank Terry and Ed Aranga for the opportunity to speak, and also to thank everyone at Holistic Health. Go over to the booth, say hi to Scotty and Chrissy and Kelly, because they're the support for the program, and also Erin and the rest of our cyber moms for helping to communicate and answer questions. It's going to be a lot of information this afternoon, and I just want people to know you don't have to feel like you understand every single solitary slide. Is this too loud, or it's good? Okay. The purpose of the first part of the talk is to give peer-reviewed scientific journals, articles written by others that help to support what we're doing in the Helicobacter part of the program and why. So that it's not just because Dr. Amy says to add carnitine, but there's a rational reason for it, and there's literature to support it. And it doesn't mean that you have to take in and read every single article that I'll present, but this way we have it on the PowerPoints, it's being videotaped, and so a week from now, a month from now, a year from now, if you want to go back and say, why was it that she was saying we needed to do this? Or what was the academic support behind this statement that she made, that in fact you'll be able to know and go back and look and see in those PowerPoints. And I just mention that because I'm going to fly through some of this data because there's so much I want to present to you. And so look at it more as a reference that you can go back to rather than trying to get your arms around all of it at this moment. The other thing is, after we go through the support for why we're doing what we're doing and why I'm so concerned about Helicobacter, then I'll show you some data from files so that you have a sense of what to look for when you go back to your doctor, or for the doctors in the audience in your patient files, so you can see what I'm looking at that's getting me to the point to say, yes, this is a concern, or no, it's not. Then we'll have another PowerPoint that's more about the scientific support behind it, and it's a really critical one because it's the connection between what may be going on with the cystic fibrosis transporter gene and sensitivity to Helicobacter in those with reduced methylation. And so we've actually absorbed the cost of an entire SNP panel just for cystic fibrosis and run a number of samples to rule out specific mutations, but in fact methylation does predispose to problems in that direction, and so that's a very critical new piece of the puzzle. And then finally, we'll look through data that explains and supports why I'm so concerned about low lithium levels. And then, if we have time, we'll do some Q&A. So again, what we'll do is first look at papers and the scientific reasoning behind what we're doing, look at the multiple pieces of the puzzle, and there's multi-steps to this program. It's a lot of work. I don't want to pretend it's a single magic bullet. But I know that we're seeing a tremendous amount of success stepping through this with the hard work instead of looking to use just one supplement at a high dose and hoping it's going to balance everything. The way this program works is to look at the molecular biology, what's going on with the genes, the biochemistry in terms of the intermediates we can actually follow in a test, a urine test, a fecal test, a hair test, a blood test, how we bypass this with supplementation, and then some of the newer parts of the program that we're looking at. In addition to the nutrigenomic test, what we've recently introduced is something that I call a comprehensive program review. And that's an 8-test biochemical test packet that you can purchase where I do not charge for my time in going through that information. You do need to pay for the test though, so you have to think about this and purchase it wisely. And I will go through this bank of 8 tests and make suggestions about it based on the kinds of information I'll tell you about today, so that you don't have to understand all of it. Your doctor doesn't have to understand all of it. I'll go through your test and make suggestions based on this information, and then you go back to your doctor and have your doctor implement it for you. And the idea behind the bundle in this comprehensive review is to make it easier to use the program, to streamline it, and to simplify using the doctor you want to use for working with, even if they don't have their arms around this program. So, let's see. Just some additional resources if some of you don't make it through the whole 4 hours. We're going to be having a conference, a Dr. Amy conference in October in California from the 7th to the 9th, which is over Columbus Day weekend. There's more information at the booth about it. The format of that will be very different than what we're doing today. I'll review the pieces of the puzzle of autism, and then for most of the conference, we have an overhead projector. You bring your questions, you bring your data, you bring your file, and I stand there basically for 2 days, and we put your data up so we can look at it and go through it and analyze it for you. So it's very personalized question and answer based on your data or data questions the doctors have on patient files. So that's in October. The other thing is take advantage of the chat group. Erin was walking around before, I'm not sure where she is now with the raffle ticket, there she is. And if you have questions about how to join the chat group, it's a wonderful resource. The other thing, again, these comprehensive program reviews, if you want my help going through the file, taking a look at the tests, making suggestions, and information on those comprehensive reviews is at the booth. And then to take advantage of the other books and DVDs, we have a lending library. You don't even have to buy a DVD or a book. You can borrow it in order to have supplemental information. Now, Missy, my oldest daughter, who's a graphic designer, has redone our chart or our pathway map to simplify it a bit, even though I know it looks complex. But at this point, you'll notice that we have the Krebs cycle as part of it, as well as the ACAT mutation on here. And the motivation for redoing this pathway is that now that Helicobacter is such a critical piece, it helps to connect the left side with the right-hand side of the pathway. And so what we've done is we now have a cycle and a circle that almost encompasses a globe. And the reason that we're so focused on Helicobacter is a lot of the factors that we've been dealing with in autism for a long time, whether it's problems with milk that create issues, too much B6, breakdown of glutathione, excess stomach acid, high norepinephrine, which is involved in ADD and ADHD. All of these factors actually increase H. pylori in the system. And then the effects of H. pylori include playing a role with neurotransmitters, creating neurological issues, tie-ins to schizophrenia, which is related to imbalances in serotonin and tryptamine levels, actually decreasing levels of B12, decreasing levels of iron in the body, increasing ammonia and taurine, depleting manganese, which again affects serotonin and tryptamine levels, having a significant effect on arginine levels, and we'll spend some time on this later, that can create a state of ketosis, and ketosis alone is enough to cause psychosis in some cases. Also shifting the energy usage from glucose in the Krebs cycle to breakdown of fats, which again feeds into a state of ketosis. Helicobacter can create issues with glaucoma, and although we normally would associate glaucoma with older individuals, we've actually had an 8-year-old child developing glaucoma, and now it's starting to get into better balance by addressing Helicobacter. Secretin was a hot topic years ago, and surprisingly, to me at least, H. pylori depletes secretin, and so it may be even affecting the gut and speech from that vantage point. It will increase leaky gut, it affects polyamine levels, and we'll talk about those in a while, and it also affects the phospholipids and membrane fluidity. And so it's not just about a gut bug. This has so many insidious effects on the body that it's become a key part of what we're looking at with respect to the program. And so again, what I'm saying, and we'll look at the globe in a moment, is the left-hand side of a pathway we normally look at is going to be connected with the right-hand side by virtue of Helicobacter. And so and unfortunately, we have no way to show the video of this right now, but what we've done is overlap this so you can see that both sides of the cycle are now connected. And so if you look at a globe almost now, the pieces of the puzzle we were looking at earlier are now totally connected in a cyclic fashion by virtue of the impact of Helicobacter on the biochemistry of the system. And so we can work our way around and see that we're connected all the way around. And this is part of why I think this is worth a good portion of this 4-hour talk today. So what is Helicobacter? It's a spiral-shaped bacteria that lives in the lining of the gut. It's responsible for stomach ulcers, it's responsible for gastric carcinoma, and 2/3 of the world's population presumably has Helicobacter, but what's important to look at here, and this gets us to the why that we'll talk about in a later PowerPoint, it's generally found in older adults, in lower socioeconomic groups, in third world countries. And so the question is, why are we seeing such a high prevalence of Helicobacter infection in young children that aren't in lower socioeconomic groups and we're not living in a third world country? And sometimes those who have Helicobacter don't even know that they have a problem with this organism in the body. And this is recent from the Illinois Department of Public Health. And I'm sure that every state has that, but since we're in Chicago, it seemed appropriate to pull their information. This is the organism we're looking at. And we can almost view what it does in the lining of the gut. It's almost like a parasite, because you're going to see in a few minutes, it burrows down into the mucus layer of the stomach, and then it's stuck there. And that's why it's so hard to see on so many of the biochemical tests that we run, because it's hiding. And it will hide for long periods of time, and it's extremely difficult to eradicate. And again, all of the information I'm going to show you in this first PowerPoint is not my information. It's all coming from articles, books, third-party peer-reviewed literature to support the reasoning and rationale behind the focus on Helicobacter. And the relationship between bacteria and the host in the intestinal tract is critical. And I know we've spoken about this before, but you have your normal flora, and then you have this protective mucus layer with your phospholipids. And normally we get absorption through cells and some absorption between cells. But this is what we want things to be looking like. Helicobacter activates enzymes in the body that increase the level of something called claudins. And I'll get back to those in a moment, because I've talked about claudins before in PowerPoints. And the claudins increase epithelial permeability. So what this is essentially saying is Helicobacter is able to increase the level of intermediates in your body and cause leaky gut. And so now, instead of working our way as we want to, we're getting through these cells, and invading organisms are triggering inflammatory pathways in the body. And some of these toll receptors will be something else I'll speak about later. And so when we look at the food allergies that so many of the kids have and food sensitivities, realize there's a difference between an IgG food sensitivity and an IgE allergy. And because Helicobacter is allowing foods that should be staying in the gut to get through the system because of leaky gut and now be exposed to your blood system, and your body can make IgG and react to it in a way that it shouldn't. And so many of these food sensitivities we see can be secondary to Helicobacter infection and leaky gut. And so again, we're looking at this lovely protective layer the gut is supposed to have, and this thick mucus layer. But if we can get through here and create problems, now the bloodstream has access to foods that should be sequestered in the stomach. And so, as I mentioned, we've talked about claudins before. Where have we talked about them before? When I talked about William-Buren syndrome, and individuals with William-Buren syndrome have excessive amounts of language, but duplication of the genes in that area causes lack of language and causes apraxia. And right in the middle of this region where we're looking at genes that seem to be tied together with language and apraxia, we've got those same claudins that Helicobacter is having an impact on. So let's just go back a moment. Helicobacter is increasing the level of claudin 4 and 5, and that can create leaky gut. And when we have too much claudin, that also creates issues with apraxia. And so this is the article that comes from, looking at duplication of this region, increasing claudins that are tied together with Helicobacter, as well as language issues. And as I spoke about in the beginning, we're going to talk about how Helicobacter can have an effect on ketosis, and the state of ketosis induced by Helicobacter may also create issues with language and apraxia. And again, looking at the relationship of some of these genes, the claudins, and playing a role in this trigger between language delays and strength in language. Because not every child who's autistic has apraxia, but I know so many of you struggle with that piece. And it's one of the pieces I continue to look back at and say, what else can we do to improve language and get beyond apraxia? And what we're seeing when we use the Helicobacter program for many of the kids, it's making a major difference. Claudins are always also tied together with other signaling genes, and we'll talk about lithium later, but again, just tying together for you, lithium, the claudins, WNT signaling, and Helicobacter. And to again reiterate, I don't expect you to remember all these points. It's too much information, it's too much science, but I'm trying to give you an overview so that in the next part of this talk, when we start to look at the data, and you go, wow, I've seen that on my child's test. Yes, we do have high subaric all of the time. Yes, we do have low manganese. That you'll be able to go back to some of this and understand the why behind the pieces of the program to address this. And so again, we've got claudins involved, we've got WNT signaling, and this is involved with leaky gut, and part of the pathways involved in language development and triggering. And again, the same WNT signaling that lithium plays a role in, and looking at the claudins and how leaky gut, claudins, WNT, lithium, Helicobacter may all be pieces of the larger puzzle we need to work on in terms of restoring language. And so again, looking at the fact that we don't want to have leaky gut, we need to restore the integrity, and part of that is dealing with Helicobacter. And just to digress a moment, vitamin D plays a major role in the integrity of the intestinal tract. And I talked a lot yesterday to the doctors about the use of some of the newer sprays that we're using, as well as RNAs. And that's twofold importance. Number one, because they're nanoparticles, I think we're doing a better job of getting them into the body. But when you're using a spray in the mouth or an RNA in the mouth, we're not relying on the gut for absorption. Because in a sense, it's a little bit of a catch-22. If we have gut issues and we're relying on capsules and tablets we're swallowing to heal the gut, but the gut is leaking, it makes it more difficult to address that issue. And so by using oral absorption to try to help some of these areas that are biggest problem areas, we're in a better situation to be able to have the body absorb some of those capsules and tablets. The role of autism and vitamin D. So it's not just that I'm talking about the fact that vitamin D is important in the mucosal layer, but also others are looking at the fact that autism and vitamin D deficiencies are related. Vitamin D also plays a role in terms of oxidative stress, and I talked a lot last summer about thioredoxin and how that balance with COMT plays a role with dopamine levels. And we don't have time to go over that today also, but you could look at some of the PowerPoint slides from the past summer in Boston, and again, vitamin D tying into that piece of the puzzle. Vitamin D also decreases some of the inflammatory activity that we're seeing. And at lunch yesterday, I was talking to Dr. Usman a bit about the major amount of PANDAS she's seeing and some of those behaviors, which are very tied together with NF-kappa B and TNF-alpha levels. And vitamin D alone seems to be able to pull some of these TNF-alpha levels down, which is tied together with behaviors as well as inflammation. We also have a tie-in between this inflammatory mediator, TNF-alpha, and Helicobacter infection. And so I'll keep coming back to this theme today that many of the other imbalances that we're seeing do tie back together with Helicobacter and the problems that we see with Helicobacter. And so Helicobacter infection, increasing TNF-alpha levels, and TNF-alpha alone is enough to increase CBS levels. And for those of you that are seeing high levels of taurine and ammonia on a UAA and who may not have a CBS mutation, it may be secondary to a Helicobacter infection in the body, increasing TNF-alpha, or other organisms increasing TNF-alpha that then boost that CBS activity, increase the taurine, and increase the ammonia. This is a critical slide. It's a scary slide. These are animal models of Helicobacter. An animal model of one type of Helicobacter and a second animal model of Helicobacter pylori, which is what we're seeing in the individuals we're looking at. And these are the mucosal cells. And in this lesser Helicobacter infection, we are seeing that it's invading the mucosal cells, but not as deeply. But when we look at Helicobacter pylori, look at how deeply it's infecting those mucosal cells lining the gut. And if we look at the percentage of it, you can see that it's distributed throughout the mucosal cell layer. And so it's no surprise that it's hard to see on a test, and it's extremely difficult to eradicate. Even standard methods using acid inhibitors and using high-dose antibiotics can't eradicate this organism. And Helicobacter will bind to the mucins which line the gut and use them as a way to get into the system. But we're going to use this as a tool to help us to go after it with some of the supplements that we use. And so if we look at the surface of the cell membrane, and we look at the mucins that are sitting there and the mucus layer, that's supposed to protect us from microorganisms and irritating substances. But Helicobacter will come in and actually bind to this protective layer so that it can get into those cells and burrow into those cells and create an infection. And we have specific mucins that are involved, and we'll get back to this later, but mucin 1 in particular, certain mutations in mucin 1 make it more likely to have a Helicobacter infection. But there's also supplements. Right now we've been using Air Power, but it's a form of guaifenesin, and that actually helps to block the binding to that mucin 1 layer. So again, there's a reason behind the supplements I suggest. There's a reason behind every single part of this program. And even if you don't remember the reason behind everything, at least now we have it down all in one place so you can refer back to it in the future if you need. This is part of the reason why we're using baking soda with meals as part of this program, but any sort of bicarbonate will be fine. What we're looking to do is disorient the Helicobacter in that mucus layer where it's burrowed down, so it will come out of hiding, and the supplements we use can get at it. And so the Helicobacter lives deep in this mucus layer, and it's very difficult to get it out. Even fussing with the CO2 levels, urea levels, ammonium gradients aren't sufficient to disorient it. So what you're looking at is the Helicobacter is down here. And whether we're just trying to deal with pH changes, trying to deal with CO2 changes, the bacteria are still oriented. But when we play with the bicarbonate level, as well as trying to address that pH, now we have a loss of orientation. And diagrammatically, you can see the Helicobacter now comes out of hiding. If it's out of hiding, we're in a better position to try to address it. Okay? And so that's why I have many of you cycling on and off the baking soda, the peptamycin, the HELX, so that we can trick it to come out of hiding, use supplementation to try to address it, and then give the system a rest so it thinks it's not being attacked anymore, and then cycle back to it. And again, you can see that we have the mucus layer. If the gastric pH is at pH 3, the Helicobacter is hiding. Even if we can get that pH to 6, it's still hiding. But if we can disorient it with bicarbonate and try to neutralize that gut pH, we can get it out of hiding, out of those layers where it's hidden, and be able to address it with some of the supplementation. And so triple therapy is what standard articles are looking at, so that we're dealing with acid suppression, bicarbonate, and pH regulation. And I know that I spoke with someone earlier who was saying, well, we're so concerned because if the stomach acid isn't there and we're not getting digestion. But the reality is, and we'll get to that in a little bit, Helicobacter is neutralizing your stomach acid anyway. It's attracted to stomach acid, it binds in a higher acid pH, and then what it does is it neutralizes your stomach acid by using up intermediates in your body and making urease and urea to neutralize your stomach acid in any event. And so when you're adding acid for digestion, you're actually helping to create an environment that Helicobacter can do a better job binding. And so I think the root to the problem is to adjust this gut pH, to try to adjust the bicarbonate issue, deal with supplements, antibiotics if you so choose, to try to get at the Helicobacter once it's out of hiding, and then we can get back in a position where we can have normal digestion progressing. So as I just said a moment ago, what allows this Helicobacter to bind to cells is an acid pH. And so if we look at pH 7.4, which is an alkaline pH, we don't have as much Helicobacter binding. The minute we're at an acidic pH, we've got almost 4 times as much Helicobacter binding. And why would we have an acid pH? Well, most of the kids on the program and the adults that we work with chronic fatigue are deficient in B12. The body will create more acid to try to pull B12 into the system. And so if you're deficient in B12 to begin with, your body's probably making more stomach acid. Now we have more stomach acid, the Helicobacter can bind. One of the effects of Helicobacter is to further deplete your B12 levels. And so we end up in this catch-22 that the way to get out of it is to try to address the root of the problem, in my opinion. So how does Helicobacter cause damage? They can move through the stomach's protective mucus lining. They create an enzyme called urease, and then it neutralizes your body's stomach acid so it can survive the acid environment that attracted it in the first place. Okay? So what it does to deal with the harsh environment of the stomach is that it simply neutralizes that stomach acid by utilizing enzymes and intermediates in the body. And so what it does is it converts urea, which there's plenty of, using urease to neutralize the acids in the stomach. And it produces ammonia. We see so many of those tests with high ammonia, and this is just one of the ways in which it's producing ammonia. And so to look at it again another way, the chemical reaction that's going on, but all you really need to look at is you've got the acid environment in the stomach. And remember, we probably have a more significant acid environment if we have a B12 deficiency. That's attracting the Helicobacter in the first place, which can burrow down through the mucus layer. And then what it does is it takes advantage of intermediates in your body to neutralize that pH, generating ammonia and urea. And so it survives in acidic conditions by producing urease through the hydrolysis and using urease, creating urea, yielding ammonia, and increasing the pH of the environment. And what we're going to look at in the next PowerPoint that we go to is the actual data that we see. And how many of you see on a test really low pH or really high pH? Or you run a GI function and a CSA, and the CSA shows low pH and the GI function shows high pH. These are all indicators that Helicobacter may be an issue. Because if the environment is acidic, you've got to wonder and be concerned, is it attracted? And then if you've got a very high pH, you've got to wonder, does that mean Helicobacter has produced urease and is now neutralizing the pH of the gut? And so again, more data from PNAS showing that what Helicobacter does is to take that stomach acid and neutralize it and break down actually the mucin protective layer. And we'll get back to this whole concept of mucin and the elasticity of the mucin and the mucin protective layer when we look at the role of functional CF deficiency that may be going on in many of the individuals. Also, by playing around with this mucus layer and hiding, Helicobacter creates a situation where your normal defenses can't get to it. So our T cells, our killer cells, or other white cells can't get there because we've got this mucus layer barrier. And so by getting it out of hiding, we make it so that the Helicobacter is more available naturally to the immune system. This is another very critical slide because we're looking at what happens initially when it binds with a very low pH, what happens with early infection, chronic infection, and then over time it's affecting the ability of the body to create acid to break down food, but also why we have such a long-term chronic problem here. This isn't just an immediate acute infection we're dealing with. This is something deeply seated, burrowed down in the body that may take months or based on some literature, years to eradicate. In addition, Helicobacter can affect feeding behaviors and neurotransmitters in the body. And this effect will persist even months after Helicobacter has been eradicated. So even if we can get it out of hiding, we can eradicate it, we may be seeing the consequences of Helicobacter in the body for 2 to 6 months after we no longer have an infection. And that's part of the reason why I want people to cycle on and off using the program to address Helicobacter so we can see what's going on in the progress we've made while we were addressing it, to take a break, take a window, and see if we've got restored language and less leaky gut and balance in some of these neurotransmitters. And so Helicobacter infection alone, it's not just a gut issue. It's not just about ulcers. We're looking at impaired acetylcholine release. We're looking at a huge number of imbalances that affect feeding behavior as well as norepinephrine and epinephrine issues. And you're looking 2 months post-eradication, and we're still not up to control levels, even that long after eradication of Helicobacter. Also, Helicobacter alone is able to affect TNF-alpha levels, and these levels persist for a long time, even after we've eradicated the infection. And so even after you've been on a program to address Helicobacter, don't be looking day one to say, oh, it didn't make any difference. It could take 2 months, it could take 3 months. Some of the other literature I'll show you, it could take 6 months to see a difference even after you've successfully addressed it. And so again, just looking at how long it may take infection sequelae in the CNS system to resolve, and they can persist even after eradicating the Helicobacter infection. And just again, reiterating the fact that the whole vasovagal response can take a long time to balance back after we get the Helicobacter infection eradicated. When we look at how it induces bile reflux and the injury it can do, and again, looking at the fact a long post-treatment period is necessary, and these investigators feel that it can take even 6 months post-eradication to see a difference. So far, and I'll do this a couple times in this PowerPoint because there is so much information. Where are we? It's attracted to an acid pH. Why do we have an acid pH? Probably because the methylation cycle isn't balanced and because we don't have enough B12. It reacts by making urease, raises the pH, and it generates more ammonia. It can establish a chronic long-term infection, and even once we've eradicated that infection, the consequences of that can last for months. It can cause leaky gut, increase food allergies, impact language potentially. Okay, and so now let's move on to the next part and see what else it can do. The way that it works on the system is to really imbalance arginine levels and affect the level of an enzyme called arginase. And this is at a very critical juncture. And so the body has a choice. It can take arginine and it can go this direction, or Helicobacter forces it in this direction. And there's going to be a lot of consequences of depletion of arginine, including imbalances in the mitochondria, reduced mitochondrial energy from glucose, potentially ketosis, which can lead to psychosis, as well as imbalances in these polyamines. And I've spoken about polyamines in the past. I won't get into a lot of detail, but suffice to say, polyamines help to deal with how your body addresses environmental stress. And so whether it's physical stress, whether it's emotional stress, whether it's cortisol levels, whether it's heat shock, the body reacts by telling cells to live or program cell death to die based on some of these polyamine levels. And Helicobacter throws off this balance and throws off the balance of the polyamines, depleting levels of some of the polyamines that may be more helpful, making more of the polyamines that may cause some problems, and in the process, depleting our SAMe. And so just another slide showing this another way. Arginine is sitting at a pivot point, and it can go this direction to make more urea so that the Helicobacter can neutralize the stomach acid, or make some of the intermediates that help to relax blood vessels like nitric oxide. Only Helicobacter is hijacking the arginine and pushing it in this direction rather than this direction. And when it does that, and I've talked about manganese a lot of the parents who are on our site know how focused I am on low manganese levels as an indicator that Helicobacter may be an issue. The arginase that Helicobacter uses has 2 manganese metals in there, okay? And so if we're overusing this enzyme and depleting manganese in the process, again, it's starting to tie together what we see on your biochemical tests, the indicators to say we may have a problem in this direction, and the why behind the problems in this direction. And I know a lot of the parents on the chat group for a while now have been saying, well, why are we seeing low manganese? Why are we adding baking soda? Why the gut pH? Is it really acid? Is it really alkaline? And at the time I said it's too complicated to try to write in one long post for the chat group. And I think you're starting to see now visually how many of these pieces come together to create the nightmare that we've got with the Helicobacter infection. And I would say that when I go through the files, easily I'm seeing 90 to 95% of the files that I look at have indications of Helicobacter. So this isn't just a low little 10% of the population that I think we have a problem with. we're looking more 90, 95%. And this is significant and serious consequences. And there are a number of indicators we can follow to see that it's an issue. But it's a committed long-term treatment to try to address it. And clearly, I think at this point, you can start to see why it's so important. And so again, to reiterate, Helicobacter is using up arginine, breaking it down, using it for its own purposes, which create even more imbalances in the body. And we can look at arginine levels on a UAA as one of our indicators. Now, we already talked about the fact that that arginase that Helicobacter uses has 2 manganese molecules. And when outside individuals are looking at what's going on in diseases created by Helicobacter, and in that gastric juice, we're seeing high levels of manganese and aluminum. And we've talked before about the role aluminum plays with seizure activity. There's a reprint of the article Nancy and I wrote at the booth, if anyone hasn't seen it. We don't have time today to get into it, but I would recommend taking a look at that article, because aluminum on its own has its own nightmare of issues you want to deal with, and aluminum is very tied together with chronic bacterial infection in the body. Looking at the fact that in addition to the arginase, and in addition to seeing manganese levels in the gastric juice, that Helicobacter also has another enzyme that's unique in using manganese. And I've talked about uridine and UMP before. It's one of the nucleotides and one of the reasons you want to be supporting with RNA and nucleotides. But you really want to be thinking about uridine, because this is part of that cycle that's helping to fuel your mitochondria. And so when we look at mitochondrial energy, and we look at the role of uridine, and we look at it getting across that blood-brain barrier, and then compound that with the fact that Helicobacter is shifting our emphasis from the Krebs cycle and energy for that mitochondria over to breakdown of fat and ketosis, you start to see why we're seeing some of the mitochondrial issues that we're seeing, aside from all the other aspects we've talked about in the past. Uridine is very important in terms of memory and learning, especially used in conjunction with DHA. And so if we look at how long it takes to reach an answer, basically, if we compare a control to once we have uridine and DHA in there, significantly less time to reach a conclusion if we have the proper support. And if we look at how long it takes the delay in memory testing, significant differences if we have appropriate uridine. But if Helicobacter is depleting our uridine as well, it's not surprising that we have imbalances in some of those areas. In a moment, I'm going to show you that Helicobacter also throws off our phospholipids. And again, DHA and phospholipids and uridine are critical in terms of looking at the synaptic connections in the brain. And so, again, you can look back at this later if you need. The bottom line takeaway message is that phosphatidylipids, phosphatidylserine, phosphatidylcholine, and ethanolamine, combined with uridine, are important for diet, memory, synaptic vessels. And when we look at synapsin, it's important in neurotransmitter releases at the synapses. And where I've talked about this before is the negative impact of tetanus and tetanus toxin on synaptobrevin and neurotransmitter release. And so those of you who feel that the DPT may have had an effect in synaptic vessel release and some of those communications between the neurotransmitters being impaired at that point, having DHA, having uridine, having the phospholipids function properly so that we have more levels of the synapsin that can help with that synaptic vessel release. But if we have H. pylori in the system and we're already upsetting that uridine balance, and now it's upsetting the phospholipids, changing the way these important phospholipids are laying in the membrane. And so one of the other indicators we look at when we look at Helicobacter infection is to look at a UAA. And if your phosphatidylserine and phosphatidylethanolamine levels are looking low in spite of significant support, you want to be thinking, what's happening to it? Where is it going? Is Helicobacter a factor here? And the reason I'm harping on other indicators of Helicobacter, whether it's looking at a high pH or a low pH or phosphatidylserine levels or uridine levels or looking at low manganese, is remember, it hides in those mucosal layers. A negative antigen test is not necessarily indicative of no Helicobacter infection. Even a negative test on the PCR test from the GI function isn't an indicator, and we'll look at that in a moment. You can get a negative test and 2 months later get a positive test. And that's why we want to run this comprehensive panel of tests and look across the board at these 8 tests and say, do we have indicators every step of the way? And so at this point, again, to take a little summary break, we want to be using a phospholipid mix. I prefer phosphatidylserine, ethanolamine, choline. We also have that in the methylmate A compound. We want to be looking at, we use neuramines, but some form of DHA. Supporting the methylation cycle with methylmate A, methylmate B, and the use of methylation RNA to try to balance some of those uridine levels. That's the role of the methylation RNA, to help with uridine balance. To look at some of the compounded supplements for AHCY that include uridine and nucleotides, or use a source of nucleotides. And something I haven't touched on yet today, but have talked about earlier, bowel RNA to try to help with that leaky gut, and a multifaceted approach to Helicobacter. Using a single supplement or medication to try to deal with it isn't going to be the answer. And as always, you want to be working with your doctor. If your doctor isn't conversant with the program, run a comprehensive review. I'll make some suggestions, and then go back to your doctor and work on this. You don't want to leave the Helicobacter infection untreated. Some of the slides we'll see later, you can see how the number of that organism will just increase over time. Again, looking at this Helicobacter arginase, and it's not just that it has manganese, but it's unique in that it pulls in cobalt. Cobalt is what's critical in B12. And I don't know if the use of cobalt by Helicobacter is why Helicobacter significantly depletes B12 levels. But we'll see some articles in a few moments that show Helicobacter infection is associated with low B12. Also, the whole male versus female balance in autism. And testosterone plays a role with these arginine and ornithine metabolizing enzymes. And so if you're male, these enzymes, the arginine pathway and this arginase, are going to even be more susceptible to imbalances with respect to Helicobacter than we see in females. And so if we look at the levels that we're seeing in males with testosterone, okay, the difference in those levels and how much more subject to depletion we are if we're dealing in males versus females. And so again, testosterone playing a role with these enzymes, and also the polyamines that I've touched on and I'll talk about a little more later. And this ties into a very recent article. I spoke about this yesterday with respect to methylation in the doctor's workshop, but sex hormones playing a role in autism and regulating a particular gene that's differentially expressed based on testosterone or estrogen. And so testosterone levels increase and play a role with respect to this enzyme. Estrogen affects it differently. And methylation is the key to regulation of this enzyme. And so we come back around to methylation, which I'm not talking about much today because we don't have time. But the PowerPoint slides that I uploaded before this conference are about methylation. We've got prior conferences on methylation. But suffice to say that methylation is critical, important, I'm not ignoring it, and plays a role in terms of regulation hormonally with respect to this gene. And so again, epigenetics, methylation, changing the way the genes are expressed, including this testosterone and hormonally affected gene. And again, looking at differences in methylation and unmethylation of this gene, well, whether we're looking at autistic and control individuals. These are all of the genes that are affected by methylation, looking at differential expression, in the same article looking at methylation and autism. And a continued list of genes that are affected by methylation. And so not only can testosterone increase arginase levels, but H. pylori is shifting the focus to increased arginase. This in turn is depleting arginine. Arginine can lead to ketosis. Ketosis can lead to psychosis, and this can be a particular problem for those who are ACAT+. And so looking at the diet, and I know that it wouldn't be the norm to say that we should be using a carbohydrate-rich, protein-poor diet. But the reality is, if you're seeing ketosis, this is one way to snap you out of ketosis, to be using more carbohydrates. Particularly because in the absence of carbohydrates, the body is going to use arginine for a carbon source. And so if we've got ketosis, and we're breaking down arginine, and we're using arginine as our carbon source, now we're compounding this problem that may be created by the Helicobacter. And so we're going to see some of the tests in a little bit, but lack of carnitine, high subaric, is a key indicator, in my opinion, of Helicobacter infection. And one of the ways to deal with ketosis is to support with more carnitine. And so carnitine supplementation, aside from going to a slightly more high carbohydrate diet, is one of the ways to get rid of the ketosis that we deal with. And getting back to one of the slides I showed you earlier, when we have ketosis, that can be a factor in some of the apraxia that we're dealing with. Just again reiterating that if you have an ACAT mutation, it may be more of a problem, and you want to be particularly aware of states of ketosis. ACAT mutations on their own can deplete carnitine, create metabolic acidosis, affect speech, and cause apraxia and aphasia. Also can have negative effects on the kidney. And so what we're talking about, again, just looking at it visually differently, the ACAT mutation playing a role with fatty acids, carnitine playing a role, and all of this being critical for the mitochondria. And so just getting back to this whole concept of mitochondrial insufficiency and mitochondrial disorders that are now impacted not just by ACAT mutations, but also Helicobacter playing a role in this process. Helicobacter breaks down and creates ketones as a way to have energy. And so rather than using sugars and glucose, it's relying on the breakdown of fat, creating ketone bodies and creating ketosis. And so another way to show you that what Helicobacter is doing is breaking down and creating ketones in the body. And so again, it's not just Dr. Amy saying this, but multiple forms of the literature talking about the fact that H. pylori doesn't use sugar for energy. It's going to rely on breaking down that arginine. It's going to rely on creating ketosis, breaking down fats, and throwing off the mitochondrial Krebs balance. And again, the low rate of glucose use, because it's relying on breakdown via the route of ketosis rather than the balance we want to be seeing. And so to show it to you yet another way, fats, When we're breaking them down, we're depleting that carnitine. That's why that MAP test and looking at the subaric levels, go back and look at old tests. Some of you, I bet, if you go back through your history, you've had a sky-high need for carnitine for years, and even supplementing carnitine wasn't sufficient. And part of the problem is going to be that if you haven't gotten to the root of the problem, you're going to have depletion of carnitine regardless. And instead of feeding into other parts of the Krebs cycle, we're feeding this direction with Helicobacter. Also, to look at the intersection of where ACAT is feeding and the high levels of taurine that we see, Helicobacter also is going to generate some of these high taurine levels. And when we have problems from Helicobacter, using the ketogenic diet is just going to exacerbate it. And one of the young girls we work with who did have sudden onset psychosis, it was after using the ketogenic diet. And she has other imbalances and issues, but just keeping in mind, if you have an ACAT mutation, and if you are going to use the ketogenic diet, keep a really close eye on ketosis. Look at those MAP tests. Use the other types of urine tests specifically for ketosis. Work with your doctor on it. Because the efficiency of the Krebs cycle is reduced when we have that ketogenic diet, and we're not getting energy to the mitochondria. And just looking at it another way, that we're seeing increases in these intermediates on the MAP test instead of sitting in the Krebs cycle for the Krebs energy that you want when you have ketosis. And again, just the fact that ACAT mutations exacerbate this. And so what we can see is that adding in carnitine support, getting some glucose support, going to a high carbohydrate, low fat diet are actually some of the tools to get out of this state of ketosis. And what we're going to see oftentimes is this lactic acidosis when we have those ACAT mutations. So that when we're having problems here and we're not feeding into the Krebs cycle, one of the other clues you may see is we shunt this direction and very high levels of alpha Kg on your MAP tests. And so if all of the subsequent levels of intermediates on your MAP are low and you've got high alpha Kg, it's another indicator. And again, we're going to look at that data directly in a little while. Just trying to show you this relationship, the use of glucose that feeds into your Krebs energy cycle. And if all you're doing is breaking down fats, you're not feeding into this cycle appropriately. And we get back to arginine again. Arginine helps to protect you against the effects of not being able to use glucose properly. But if we have Helicobacter in the system, and we can't, and we're using the arginine to break down via arginase to neutralize stomach acid, we don't have the arginine we need to balance the glucose imbalances. And so what can happen? Well, we can have problems with psychosis, that mitochondrial issues alone are enough to create psychosis and imbalances. And some of the laughter that many of us attribute to a yeast infection, I'll show you in a little while, may be attributed to high levels of tryptamine, which is actually a hallucinogen that can be produced due to Helicobacter infection. And the way we know some of this is by working with individuals that are having this problem who are not autistic and can articulate the fact that they're seeing pink bunny rabbits talking to them. And then when we go and we run the tests and we see high tryptamine levels and looking at the use of things like feverfew to try to pull some of those down. And so we can have imbalances in the mitochondria, in part created by these states of ketosis, that then can create psychosis. How blood ketone levels alone, so ketosis, secondary to Helicobacter, potentially secondary to ACAT mutations, can create psychological and emotional disorders. And if we look at the effect that these ketones have on tryptamine levels, we see that tryptamine levels go up in animal models upon ketosis. And just keeping an eye on the fact that manganese and copper regulate MAOA, and MAOA is involved in trying to regulate serotonin as well as tryptamine levels. And so that if we have imbalances between tryptamine and serotonin, and higher levels of tryptamine, it will aggravate your serotonin levels. And we start to have problems with mood, emotion, sleep, appetite, schizophrenia, as well as OCD symptoms, which are related to imbalances in serotonin levels. And so some of these tryptamine levels that are out of balance secondary to Helicobacter may be causing problems with serotonin levels. And I know that there's been some use recently of supplements and patches to help to control MAOA levels, and it will break down serotonin, but you want to keep in mind you want moderation, because you don't want your serotonin levels to drop too low, and if the problem with serotonin is really high tryptamine and not lack of MAOA, you could be throwing off the balance in your body. So looking at the comparison, and they're comparing the effect tryptamine has to actually LSD in the body. And what I'll do is show you test values in a little while where some of your kids are testing really high for tryptamine levels. That's why we've added that neurotransmitter test to the panel of tests. And I know one of the moms yesterday was asking about, you know, how reliable is it with respect to dopamine and norepinephrine and epinephrine, and we're cross-checking it with the MAP test, but the key feature of that neurotransmitter test is to look at these tryptamine levels, because you don't want your kid or an adult running around with something in the system that's equivalent to LSD. And if we look at the effect that tryptamine can have, look at the 3+ for autism. That's seen just from high tryptamine levels. And it gives you a sense that if Helicobacter is throwing off the system to increase tryptamine levels, if we can get the Helicobacter infection down, can we offset some of the symptoms of autism simply by pulling down Helicobacter and tryptamine? And what we're seeing in the cases that we're using is the answer is yes, as well as seeing some positive changes in language. And just looking at this interaction between tryptamine and serotonin and this balance that goes on and how they will antagonize each other. And the fact that when we have imbalances, you can get chronic muscular spasms. So tryptamine on its own will cause repeated contractions and repeated mechanical muscle movements. And I know a lot of you in the past have talked to me about twitches and repetitive motion from your kids. And we can't rule out that high tryptamine levels aren't a factor here. Again, just looking at the fact that tryptamine and the imbalances in this serotonin level and the serotonin pathway that goes on. And so when you're using tryptophan, it can go in a few different directions, but when we have Helicobacter infection, we seem to be getting stuck at this point with high tryptamine levels. And tryptophan in the pathway we just looked at is also impacted by lead and certain enzymes we've talked about in the past. And so this is a slide I've used before, and I bring it up now because we had one young girl from Italy who was 17 years old, and the only way she presented with Helicobacter initially was bruising and bleeding issues. And we ruled out the fact that it was other supplements, EDTA, what else was going on. And finally, looking at this pathway and saying that it may be the effect that Helicobacter has on the system, the interaction between tryptamine levels here, so we weren't getting the heme we needed, went back and measured, ran a test, and sure enough, she had sky-high levels of Helicobacter. And just a side note, a slide I've used before, when we have imbalances in that pathway, it will compete with GABA, and so some of the high glutamate, low GABA levels and antagonism we see. Getting back to the psychological role Helicobacter can have and the role it may play in schizophrenia. And I know Dr. Mullen and I are working together in some instances where Helicobacter seems to be playing a role, at least for one young girl. the high prevalence of Helicobacter in institutionalized schizophrenic patients. Not to say that every individual who has Helicobacter is going to be schizophrenic, but if it's enough to create schizophrenia in some individuals, what is it doing at a lower level with some of the behaviors that we see? Some of the inappropriate laughter, inappropriate play, repetitive behaviors that we see. So it's affecting psychological issues. It's not just a gut problem. And just touching back on methylation again, because we always want to keep methylation in mind, that the role of methylation in some of these neuropsychiatric disorders and how critical having a balanced methylation cycle is. And so looking at GABA levels, looking at schizophrenia, and the importance of methylation, and the role that DNA methylation plays in synaptic plasticity, learning, and memory. So even when you're focused on Helicobacter or the gut, you don't want to forget about the critical role of DNA methylation and the role that it's playing to help those neurons mature. Playing a role of the fate of those neurons, making sure what's going on with inflammation of neurons and also activation of those neurons. Okay, so we'll take a moment again. Where are we now? Helicobacter can increase ketosis, and ketosis can be a factor on its own if you have an ACAT mutation. We want to be looking at carnitine. We want to be looking at the levels of suberic. We want to be thinking about what that means for mitochondria, mitochondrial energy, mitochondrial disorders. We want to think about the relationship of testosterone and arginase and how in males this Helicobacter infection may be more of an issue. The role that tryptamine plays, how it can affect behavior and language, and the imbalances in that aspect. And also just keeping in mind methylation and the role that it has in autism in general, as well as that RORA gene that was recently uncovered. Okay, Helicobacter and the role that it plays with bile, gallstones, and cholesterol stones. And so sometimes we see imbalances in cholesterol levels, we see imbalances in fatty acid digestion. One of the supplements or herbs that I'm using more now is Triphala. I love this herb, but you want to use it in low doses because it can cause loose stools. And a lot of the kids are already having a problem with loose stools, so the idea is to use it in moderation. I bring it up because if we go back here, we have problems with bile and breakdown of some of the fats with the Helicobacter. Triphala may help with that, and it also helps to control the amount of stool, the frequency of stools, undigested food in stool, the color and the consistency. But keep in mind if you're using it that it could cause looser stools. And again, changing symptoms associated with gut problems, whether it's the mucus, gas, belching, abdominal pain, and even behaviors. The other thing about Triphala, playing a role in terms of activation of certain genes that could play a role in language. And also, it seems to have a balancing effect on norepinephrine and epinephrine. And so when we see some of those imbalances on a neurotransmitter test, Triphala may be helping there also. Also that it helps with the bile acids that we spoke about, and Helicobacter can be creating problems with this. And Helicobacter is sensitive to these bile acids, so Triphala may help us with Helicobacter. There's also another new herb that we'll get to in a moment, Ayurvedic herb that may help with Helicobacter. Getting back to the fact that Helicobacter does create imbalances with norepinephrine, and when we don't have methylation cycle balance, and we have too much focus on the shortcut, we have higher levels of norepinephrine, and norepinephrine actually increases the growth of Helicobacter. So again, you want balance in that methylation cycle, because methylation cycle imbalances, high levels of norepinephrine may actually fuel the growth of Helicobacter. On blood work, a lot of the high eosinophil levels and mast cell levels you're seeing, eosinophilia, also may be tied together with Helicobacter. Looking at this again, incidence of Helicobacter and inflammation. And the fact that Helicobacter infection is affecting height in children and growth. And the older they are, the longer this is in the system, the more of a problem that it is, okay? So just looking at, every once in a while I'll get a parent saying, my kid isn't growing, they're not getting taller, they're not gaining weight. And I do think a lot of that is related to leaky gut and inability to absorb nutrients, which again is why we're focusing so much on the sprays and the RNAs, but also dealing with that Helicobacter infection that's affecting the growth rate, okay? And so the effect of it on children's growth may also be related to the immune response as well as depleting iron levels, and we'll look at that in a minute. But you can see, as they get older, the discrepancy in growth with Helicobacter infection gets worse. Also, Helicobacter infection depletes other critical nutrients in the body. And so in particular iron, and I've talked about this before, I won't be re-showing all the slides, but iron drives virulence in bacteria and viral infections. And a lot of your kids show low for iron. And the natural tendency is to add iron. But when you add iron, all you're doing is fueling the infections that are already there. And what this is saying is simply having that Helicobacter infection there may be depleting the iron to begin with. If we deal with that infection, we'll show in a moment that the iron levels go back up. And so reversal of iron deficiency after you eradicate the Helicobacter. But eradicating the Helicobacter is no small deal. We know it's going to take time, we know it's going to take a multifaceted approach, and it may take several months after we've eradicated it to actually get it out of the system. And again, showing that the iron deficiency is related to Helicobacter infection and certain concerns that even if we haven't diagnosed Helicobacter in an individual, that may be the causative effect of iron deficiency. Helicobacter will also deplete vitamin B12 levels. And it may be an absorption issue, it may be because it's neutralizing the stomach acid, it may be because it's hijacking the cobalt for its own arginase. Also, keeping in mind, and we'll get back to this when we talk about cystic fibrosis, that vitamin C levels are depleted also by Helicobacter. And so you start to see why some of the supplements are on that list for the Helicobacter program, including the vitamin C. It's been found to be a factor in B12 deficiency, and so how many of your kids are you adding B12 and you're not seeing significant levels? Lithium also plays a role there, and we'll get to that in one of the later talks, but the role that Helicobacter is playing here in B12 deficiency. Another article again, is Helicobacter the causative agent in B12 deficiency? So not just Dr. Amy saying that this is an issue, but multiple other authors. And again, links between Helicobacter, cobalamin deficiency, and pernicious anemia, which is severe B12 deficiency. And looking at the role that Helicobacter may be playing in B12, folate deficiency, and some of the developmental issues that are consequences of that. I mentioned this earlier, and we'll show data again, that glaucoma may be related to Helicobacter infection. And also, Helicobacter tends to have a relationship with retention of cadmium in the body. One of the other indicators that we look at is high excretion of cadmium if we're doing nothing to induce it. And cadmium levels also affect the eye. And so, as I said, we've got a young boy where this was a concern. And a lot of you sometimes will talk about, you know, the kids looking out of the corners of their eyes or rubbing their eyes or having problems with their eyes. Think about Helicobacter and the cadmium associated with it in those cases. We've talked about before the role Helicobacter is playing with that arginase, and we're going to now talk about what I mean about these polyamine levels that are affected. And so what happens when Helicobacter is using our own arginase in our arginine in our bodies and breaking it down through arginase, using that to neutralize the acids in the body and having imbalances in the polyamines. And the polyamines are these compounds. And we don't need to remember all their specific names, but the bottom line is that the polyamines are what help your body adapt to environmental stress. And putrescine is where we really want to be sitting much of the time. And what Helicobacter does is have us sitting here with spermidine and spermine. It gets there by depleting SAMe, and we'll look in a few more slides that this same imbalance that occurs is what occurs in physical head injury. And so just looking at this another way, arginine being broken down into the polyamines rather than the pathway that we would normally be having in the body for nitric acid, nitric oxide, and looking at the impact of that. And so when we're normally breaking arginine down properly, we can feed into the Krebs cycle. But we're not doing this the way we want to be because Helicobacter has hijacked our arginine to go in a different direction. And so because we're not sitting here, we're not feeding into that Krebs cycle, and we're relying more on other areas for energy, breaking down fats, going to ketosis again. And so looking at the effects of some of these polyamines on what occurs with methylation too. Lithium will play a positive role, and we'll talk about lithium a lot more later, but just keeping in mind that look at lithium levels because lithium has a way of helping to balance polyamines. Again, looking at the fact that these polyamines are out of balance with long-standing Helicobacter infection. And so this deeply rooted infection having significant long-term effects on enzymes in the body. And if we look at the longer this Helicobacter infection goes on and how severe it is, and remember, the longer it is and the deeper it's burrowing, look at this major increase in some of these enzymes for polyamines. So this is really significantly throwing off the body's natural system to adapt to environmental stressors. And we need these polyamines in order for these nerves to grow, okay? And we need, in particularly, putrescine. Putrescine is what's helping with the branching and the elongation. But Helicobacter is throwing off this balance by virtue of interfering with this portion of the pathway. And so again, we can look at what happens with arginase and polyamines and throwing off this balance of the relative levels of putrescine. And putrescine can also help us with GABA levels. But if we're taking all that putrescine and we're making spermine and spermidine, we're not getting the balance that we want. And again, as I said before, even if we have no Helicobacter infection, we see the same kind of imbalances in polyamines when we have severe head injury. And we're used to thinking about severe head trauma of affecting many of the same parameters that we see affected in autism. And so if we look at what goes on with severe head injury, you can see the increase and the change in polyamines with head injury, looking at, in particular, the increases similar to what we see with Helicobacter. And again, yet another article looking at Helicobacter increasing the levels of these enzymes that throw off the polyamines. And as I said earlier, you don't need to understand, you don't need to know all these details, but you've got references for it. So that later on when you go back and say, well, Dr. Amy is concerned about the arginine levels, you'll have some recollection of why and the impact and how many aspects of the body that it affects. And I just want to point out that this particular enzyme here, PAO, that's also increased when we're dealing with Helicobacter infection, and that enzyme uses BH4. And we'll talk a little bit about BH4 today. I've talked about it a lot in the past. We need BH4 in order to make serotonin and dopamine. BH4 is negatively impacted by the aluminum in the system, presumably secondary to bacterial infection. But if Helicobacter is hijacking the system and we have a lot more activity of this enzyme, we can be depleting our BH4 levels focused on this enzyme instead of the enzymes we need to make serotonin and dopamine. Polyamines are also important in regulating methionine synthase. So if we throw off polyamines, now indirectly we're throwing off our methylation cycle and the balance via the long root. And so Helicobacter, by virtue of throwing off polyamines, then in turn affects what's going on with methionine synthase. I just mentioned this enzyme PAO. That enzyme needs BH4, and we may be depleting some of our critical BH4 by fooling around with polyamine levels secondary to Helicobacter infection. Also, Helicobacter arginase, again, inhibiting that nitric oxide. So instead of going in the pathway that we're looking towards that ties into our Krebs cycle, we're going in another direction, throwing off polyamine levels. And again, looking at the increased oxidative stress and nitrative stress that's associated with Helicobacter infection. And so, again, the role BH4 needs to be playing in the system and how Helicobacter may indirectly be depleting our BH4 levels. And remembering to recall, I just spoke about it, heavy metals depleted, and we know we have heavy metal issues. We need our BH4 in order to make dopamine and to make serotonin via this pathway. And Helicobacter is also even impacting this level of the process. And if we look at the metals that affect BH4 levels, the manganese imbalances that we deal with significantly impacting BH4 levels even more so than any other metals in the system. And if you recall, we need BH4 so that we don't end up with superoxide. And so if we do have activity in this system and this part of the pathway, BH4 is critical to make sure we don't have additional oxidative stress. And so again, looking at the fact that if we're sitting here from arginine and going through this cycle and working with this enzyme that's using up our BH4, we start to imbalance our BH4 levels. And so we already, for many individuals, have problems with CBS mutations, or we have problems with A1298C mutations, or we have aluminum excess. And now we could probably add another leg to this stool, considering the impact that Helicobacter may be having on BH4 levels. And just again, reiterating how critical BH4 is in order to make serotonin, to make melatonin, to make proper levels of dopamine and epinephrine. Also, and I had one mom catch me just as I was signing in here, concerns about Parkinson's for herself later in life, and looking at the impact that Helicobacter eradication may have on Parkinson's disease. So we're not just talking about autism. We're talking about the fact that Helicobacter may have significant effects on a number of neurological conditions. Also, that symptomatic Helicobacter infection is involved with those who have severe neurological impairment. So not just autism, not just Parkinson's, but other types of issues that we're dealing with, as well as what we talked about earlier with the relationship to schizophrenia. The article to help to support the fact that secretin levels are thrown off by Helicobacter, and years ago there were some lovely successful studies using secretin to stimulate language. But Helicobacter alone seems to be enough to impact and reduce severely secretin levels. And so it may be that with eradication of Helicobacter, that's part of the reason we're seeing language increases in some of the kids. Also, I mentioned this earlier, that Helicobacter affecting the levels of norepinephrine. And norepinephrine then stimulates the growth of Helicobacter. And so if we have too much emphasis on the shortcut of the pathway, that BHMT pathway, then what we have is more norepinephrine. But remember, we've got the shortcut and the long route. If Helicobacter indirectly is affecting the long route through polyamines and affecting methionine synthase, and so we're relying on the shortcut and we've got too much norepinephrine, now we're fueling the system for even more Helicobacter. As many of you know, I have a problem with too much B6 because of concerns about CBS mutations, and now it looks like high B6 actually increases Helicobacter levels and stimulates its growth. Also, looking at the role that certain enzymes that break down glutathione have on stimulating Helicobacter. And so I do believe in adding glutathione, but you really want to think about the entire system when you're adding. If you're adding way too much glutathione, you may be stimulating that enzyme, and it may have an impact on Helicobacter. And again, additional articles looking at the fact that this enzyme is involved in glutathione breakdown and the role that it may be playing in stimulating Helicobacter. And there's actually a dose-dependent effect of this enzyme on Helicobacter. Looking again, a second article just saying, from my vantage point, pay attention to how much you're adding. Yes, use glutathione, but use it in balance, okay? I'm really not a strong proponent of high doses of anything, just low amounts of a number of items in the body. And that gets us to cysteine, because Helicobacter actually has a very different pathway than we do, and it causes a reverse transsulfuration pathway that's tied together with cysteine levels. And so if you are going to use some of the programs that use more cysteine than I would suggest, at least keep in mind that this could completely throw off the system if you have a Helicobacter infection. And so what this is showing is that Helicobacter doesn't function in the pathway, the methylation cycle and transsulfuration the way we normally would. It has a reverse transsulfuration that's tied together with cysteine levels. And so it may be throwing off that balance of cysteine, and then if you're adding very high levels of cysteine, you may have a compounded problem. And recall that cysteine sits at a pivot point. And if it gets too high, your taurine levels are going to climb instead of going towards glutathione. And so again, looking at the fact that cysteine plays a pivot point and recognizing that cysteine levels may be impacted by Helicobacter infection. And just again, showing you that pivot point where cysteine sits and looking for balance in this system. Again, reiterating the fact that Helicobacter may be the cause of B12 deficiency. I don't think it's the only cause, but it's certainly a strong causative factor. That some of the imbalance between the Th1 and Th2 that we see could be secondary to this effect on B12, and that it can decrease iron levels in an otherwise healthy individual. And keeping in mind the role iron plays in regulating the methylation cycle in this SHMT part of the pathway. Looking at the effect that Helicobacter has on iron, the iron stores, and we've already talked about that earlier, and that it can play a role even in brain activity, okay? And what I want to point out here is that even when they're dealing with antibiotic treatment for Helicobacter, the results are disappointing. And so the importance of a multifaceted approach taken over time, cycling on and off, using tests to follow and see what's going on. Getting back to the issue with gastric mucin that I said I would, and how balance is in there may be natural antibiotics against Helicobacter. So using the body's own natural defenses against Helicobacter. And we saw this slide earlier that Helicobacter is binding to the mucins on the cell surface. But certain mutations there create a greater problem with Helicobacter and increased binding. And so looking at the fact that the type of mucins you have may create more significant, severe, and deeply rooted Helicobacter infection. And if we look at what we're using AirPower for, or the over-the-counter medication Mucinex is for, but guaifenesin, it actually helps to block this mucin 1 expression and maybe helping reduce Helicobacter attachment so that it can't get into the cells. And we're having some very good results when we use air power in terms of an adjunct supplement in the Helicobacter program. And when you use guaifenesin, and this is another name for it, it seems to be able to help to reduce anxiety. And we're seeing reduction in anxiety also with the use of air power. When it's used in conjunction with glycine, so low doses of GABA calm, along with this air power, seem to be having a very calming effect, particularly with those who have significantly aggressive behavior or high anxiety. And especially when we combine it with the use of low-dose lithium, which I'll show you some of that data in a little bit. Okay? And that the use of air power guaifenesin also helping with some of the overstimulation at NMDA receptors, so excitotoxin issues. Originally, that was pioneered for the use of chronic fatigue syndrome and mitochondrial disorders. And so we weren't using it for a long time, and then once I was able to see that there was a rational reason to look at guaifenesin based on this mucin-1 attachment, again, having a reason behind every step of what we do in the process, I now think it makes sense to take a look at this because we now know why it probably is having a positive impact. And just the energy metabolism in the mitochondria, this is from the chronic fatigue article, looking at the role of using guaifenesin to try to help this cycle. And I believe that part of the reason it may be helping is it's impacting attachment of Helicobacter to the cells in the body. Again, getting back to the role that lithium has, and I keep harping back on lithium because many of the individuals with autism are showing up with very, very low levels of lithium, and how that even plays a role on BCL2, which is involved in language, as well as mitochondrial function. Now, risk factors for Helicobacter. What puts you at greater risk? Actually, drinking milk. And so it's another reason to be casein-free, because if you look at milk ingestion, the number of individuals who are positive for Helicobacter who have milk at least once a week, as opposed to less than once a week, is pretty significant. And so I'm not saying that drinking milk creates Helicobacter. What I'm saying is if you're not on a casein-free diet, you may be exacerbating a condition. Also, the role that blood type plays. And in the past, I've talked about the role of blood type on strep infection, and it looks like blood type O and blood type A are more susceptible than those who are B or AB for Helicobacter. And I know, or I'd like to hope none of your kids are smoking. Smoking increases the infection level with Helicobacter, but the reason I left that on there, one of the toxic elements that's so high in cigarette smoke is cadmium. And cadmium seems to be tightly tied to Helicobacter infection. And so I can't help but wonder if what we're looking at here is this cadmium levels that are playing a role? And if so, it is significant because many of the kids have so much trouble with heavy metal retention, cadmium being one of the problems. Okay, so what are we doing to try to deal with it? We have a natural compounded supplement called peptimycin that has a number of the natural supplements all in one place to help with Helicobacter, and we're going to be adding another Ayurvedic herb to that soon. We're using an RNA to help us. We're using baking soda with meals, but you can use another form of bicarbonate. We're using air power, or you could use another source for guaifenesin. We're using a range of specific enzymes, not just super digestive enzymes, but enzymes that help to deal with thick mucus in the body. And we're also going to be looking at, and I'll talk about those in a moment, some very, very specific normal flora that seem to make a difference in combating Helicobacter, and we'll probably be compounding a normal flora for that in the future. Before the talk, someone asked me, when you cycle on and off, do I want you to cycle on and off these compounds or just these? And the answer is, if you're taking a break, take a break from peptimycin. If you want HELX, take a break from the baking soda, but I would stay on the air power, the enzymes, and the normal flora. I would not cycle off of those. This comes from a post from the chat room, but just so that we have it for posterity's sake on this PowerPoint. The kinds of indicators that I look for when I look at these range of tests. I'm looking for very low manganese on a UE or a hair metal test in spite of supplementation, and by now I think you probably have a better sense of why we see low manganese. I'm looking for high suberic, which is an indicator of a need for carnitine, and I'd like to think now you can understand why we see the need for carnitine. I look for either really high or really low pH, because Helicobacter will be attracted to a low pH, and then it will create a high pH. I look for imbalances in copper levels, in part because Helicobacter is throwing off that serotonin and tryptamine level, and copper is necessary for the enzyme, the MAOA enzyme. I look for excretion of cadmium even if we're not doing anything to provoke excretion, because in a moment you're going to see data that shows that Helicobacter actually has binding proteins for cadmium. I look for excretion of bismuth because bismuth will actually help to kill Helicobacter. And so Helicobacter seems in a self-protection mechanism to start to excrete bismuth from the system even before you add it. We look for imbalances in that tryptamine, 5-hydroxyandoleacetic acid pathway, looking at that on a MAP test or a neurotransmitter test. We're looking at imbalances in phospholipids on a UAA, even if you're adding phospholipids, if they're still looking low. We're looking at imbalances in arginine levels, even if the other amino acids seem to be in balance, or even if they're out of balance, arginine's standing out because it's so central to the arginase that's triggered by the Helicobacter. And finally, we're looking at high levels of taurine and ammonia, even if there's no CBS mutation. So this is part of the reason I've gone to that comprehensive program review bundle, because as I'll show you once we get to the actual data in the next short while, you want to be looking at all of this simultaneously. You don't want to be missing Helicobacter infection. You don't want to give it 6 months to a year to get more deeply rooted because you only ran a single test and you missed it. So just some of the data supporting why we have some of the components that we have in the peptimycin. Grapeseed extract working against Helicobacter, bismuth salts working against Helicobacter, Lactobacillus reuteri, and we've recently gotten a source of this that I'm very happy with at Holistic Heal, because it looks like it directly will help to eradicate Helicobacter, especially used in conjunction with other therapies. And this is a different form of lactobacillus than we normally look at. I do want acidophilus in there, but this reuteri is specific in terms of suppressing Helicobacter. Again, just more data, a second article that combination approaches will dramatically increase the cure rate of Helicobacter if we're using Lactobacillus reuteri along with other types of supports. And again, the importance of using the right kind of normal flora to address imbalances. Also, right now we're using Supremadophilus as a source of the Bifidobacterium. This is a very specific strain of Bifidobacterium that looks like it also has activity to help with Helicobacter. And looking again at the data that shows that the Bifidobacterium may actually help to inhibit the adhesion of the Helicobacter to the cells. This is the Ayurvedic herb that we're looking at in addition to Triphala, and Dr. Mark Navu is taking a look to see if we can add this directly into peptimycin to help us from yet another angle. This is an important concept, especially as we're now about to shift to looking at the actual data that we're seeing from files. If you have other bacteria in the system, so if you've got a really bad CSA and you look to try to see Helicobacter, you may not see it because other gram-positive and gram-negative bacteria inhibit the ability to be able to see Helicobacter on a test. And so, again, just to summarize before we shift on to the next PowerPoint, Helicobacter isn't just about stomach ulcers. It's not just about leaky gut. It is impacting virtually every aspect that we see and we deal with in autism. I don't think Helicobacter is the cause of autism. That is not what I'm saying at all. But I think it's a critical enough piece of the puzzle that we've been able to tie together that cycle around the globe now by adding this piece in there. And again, the next piece we'll talk about after we look at the data, and I've already alluded to it, we shouldn't be seeing Helicobacter evidence in virtually 100% of the kids we're looking at. And the question is why? This should be a problem of older adults in third world countries. This shouldn't be a problem in young children in this country. And that's why we're going to look at the relationship a functional CF deficiency may have in predisposing to Helicobacter infection. Okay, let's see if I know how to get to the next piece. Oh, Erin's going to do a raffle while I figure out how to get the next slide up. Let's see. How do I just do the big one? Okay. Thank you. Okay. Isn't that amazing? Yeah, yeah. No, I'm good. No, I'm good. I'm good. Thanks. Sorry, guys. This is for the comprehensive methylation panel. Oh, this is for the comprehensive methylation panel, so I guess the genetics is what we're doing here? Okay. 912087. Ooh, excellent. Right, everybody's here. Okay, so that was the extent of our break, but I've broken it up so it's not all kinds of heavy-duty information. Now we're just going to look at pictures of data and note that subaric is high or manganese is low. So it gives your brain a little bit of a rest as we go through these, and then we'll get to the heavier-duty one again, kind of interspersing it, that looks at the cystic fibrosis gene. Okay. So this first helps to reiterate the fact that there may be times where you're not going to see the appearance of Helicobacter until you get a clean CSA. And so we've got a CSA that has a lot of imbalances. We work on those imbalances using other portions of the program, and if you're not on the program and you want to know how we deal with those and how we clean up this gut, you could go on the chat group or look at the list of supplements that we use for the GI support. But we do get a clean CSA. And now that we have a clean CSA and a repeated clean CSA, we take a look for PCR of Helicobacter, and sure enough, we can see Helicobacter where we might not have seen it before. And then we see reduction over time using the program. And it looks better, it continues to look better over time. See, this is easier than all those slides. We're just going to look at a lot of data like this, so you just have to look, you don't have to think for a while. And so again, we have no Helicobacter, we're not seeing it on this test. We still have some gut imbalances. We work on the gut imbalances. We get them down. Now, this is the point I was making earlier, and we're working on developing some other more selective tests. Even if you're not seeing the stool antigen test, I still worry that we may have a problem. And especially, remember I just said to you, Helicobacter will be pumping out bismuth even if you're not adding it because it kills it, so it doesn't want it there. And one of the indicators we're looking at is high levels of bismuth when you're not adding something that has bismuth in it. And sure enough, follow-up, now we're seeing Helicobacter, okay? And so once we get a clean CSA, keep an eye on all these other tests and all these other indicators. Same deal again, we've got imbalances on the CSA. We work on cleaning up that CSA. We're still not seeing Helicobacter here, but then over time we see it on a test. And so having a negative test for it isn't always enough to say I don't have it as an issue. And that's why I'm going through this exercise of showing you all the other indicators that I look at. Because if you choose not to have us run a comprehensive review, know what to look for in conjunction with your doctor in terms of indicators that may be a problem. And what I'm trying to illustrate here is, and we know this certainly now after the first PowerPoint, left untreated, it's going to get worse, is what it amounts to. And so we can look at the Helicobacter level here, and then look at the increase in the level in just a few short months if it's showing up on a test and we're not treating it appropriately. Again, not seeing anything, and then those slid, but it's showing up over time. Non-ideal CSA, we clean up that CSA, and we see Helicobacter. And in this case, we had no CSAs, but at least they ran a test to see that there was, in fact, an issue. This CSA looked too clean, and so I was suspicious. And we ran a GI function, and sure enough, we had Helicobacter as an issue. And then getting those levels down over time. And to tell you the truth, because it is so tricky, and because it can hide, even when I'm seeing reduction or elimination of it on this test, we're still probably staying with support for at least another 3 months, or cycling on and off and looking at other indicators, because I'm not trusting the fact that just because it's not showing up that we don't still have an issue. Again, non-ideal CSA, we clean up the CSA, and then we're not seeing anything here, but finally seeing Helicobacter. And cleans up over time, but again, stay with support. Non-ideal CSA, seeing Helicobacter over time. And you start to get a sense, as you're looking through some of this, how many, oh no, this isn't the slides I wanted. We're going to skip through these really quickly because we're not going to look at them because I really didn't want them, and my computer wouldn't open up, and so it's on the stick, and it just, we don't have the right slides for that one. Okay, hang on a minute. We'll see if we can get there a different way. Is there a way to get back to that stick on here? That one. I think this will be all right. I think we're okay. These are the same slides we already saw, so we're not racing through them quickly without looking at them. We're just going to get past the ones we've already gone through to get to the later slides that I want to take a look at. But my point is, this is data that you're seeing from a huge number of individuals. And so it isn't 1 or 2 or 3 or 10. But so many of the files that I'm looking at, and we probably have over 10,000 individuals on the chat group, and we're looking at files from thousands of people in our office, and I am seeing such a high percentage of them that have Helicobacter as an issue, that this is why I felt that it was worth devoting this level of time today to the problem, why it's happening, what to look for, and what do we do about it. Okay, so obviously if you have a lot of imbalances on a CSA, we may not be able to be seeing Helicobacter yet on other tests. But indicators that you want to be looking at are things like a very low gut pH, okay? And oftentimes that'll be an early indicator when the level is still low that Helicobacter is a problem, because remember, it's attracted to a low gut pH. By the time it's neutralized that gut pH and your pH is up above 7, oftentimes the problem may be more significant. Other indicators, look at your manganese levels on your UEE. Is manganese low, and are you dumping cadmium with absolutely no provoking agent, okay? So low stomach acid, low manganese levels, dumping cadmium, I'm thinking Helicobacter. And you may not always see Helicobacter initially, but a high need for carnitine and a pattern of a need for carnitine is also an indication. So looking on your MAP test, look at that suberic. Clearly we need some extra carnitine to bring it down. And this is nothing new. We've known for years that if that value is high, you want to add carnitine. But what I'm saying is, let's have a slightly different slant on it. Why do we need carnitine? Why do we need to be adding it? And if you think back to the last PowerPoint and all that information, we need that carnitine because of the effect Helicobacter is having. Then take a look at cadmium. Are we dumping cadmium for no other reason? And then what we want to do is go down to where our manganese is on here, and we see we've got low manganese in a hair test, okay? And the other thing while we're here, I just want to point out, use your hair tests and look at lithium, because oftentimes we're going to see dumping of lithium before we see lithium levels very low also, okay? We don't always see sky-high carnitine. Sometimes we see an intermediary level. And that's why I want you to run a range of tests to see if Helicobacter is an issue. And so in this case, we're seeing that we've got Helicobacter as an issue. And the suberic is high, but it's not sky-high. It's not sitting over here like we were on that last test that we looked at. If you do see a high need for carnitine, though, you really want to think about additional testing. And so if we're seeing a pattern where we need carnitine support, you want to run other tests, because this individual, this was the only test in their file. And I'm already suggesting and concerned about Helicobacter, but that's why I want those comprehensive program reviews. Going to this example where we're going to see a little more data to show you some of these other indicators. So we've got some imbalances here on a CSA. We're looking at some bismuth dumping, which is always an indicator. Now, once you're using something like peptimycin, peptimycin has bismuth in it. So we're expecting that level to be going up once we add peptimycin. But if you're seeing bismuth excretion and you're not adding peptimycin, that's a really strong indicator, in my opinion, that we want to be looking at Helicobacter. pH is very low. That's also an indicator. We're not seeing Helicobacter yet, but I would certainly look at retesting in that case. And a pattern of needing more carnitine even in spite of support. In terms of arginine, and we talked about arginine a lot in that last PowerPoint, notice how many of these amino acids are too low. Clearly we have leaky gut and we need to deal with those issues, and bowel RNA and amino acid support and amino assist. But in spite of most of these being low, arginine stands out as something that's dumping at a higher level. And so it's looking different than the rest of most of the amino acids on the test. Cysteine is at that pivot point, and so cysteine levels are sometimes going to be high or sometimes drop low, and so it's not factoring into what we're looking at here, but just paying attention to your arginine levels not following the trend of the rest of your amino acids. Again, I'm very excited about the fact that we're dumping a nice amount of cadmium, but cadmium dumping without any provoking agent is another one of the indicators that we look at. And then the other piece I'm always going to look at is manganese. And manganese is low, but it's not too bad here, which again shows you want to look at a range of tests to get a more comprehensive sense. Here again, I'm concerned because anytime I see a strong need for carnitine, the other thing is that when you see, and I didn't really talk about this too much in the first part of the PowerPoint, when you look at the Krebs cycle, and we're seeing very high levels of these two components of the Krebs compared to these components, you want to be also thinking Helicobacter, because the balance is thrown off, and so the some of the intermediates in the Krebs will be higher at that point. Again, looking at this chronic need for carnitine in this individual, and this is the neurotransmitter test that I was talking about. When we're seeing high tryptamine levels or imbalances in this region, that's when I'm also wondering about Helicobacter and also looking over here for imbalances. Manganese here, starting to drop low, again, another indicator. Looking at another example. And look, I'm excited in my comments. I'm not pretending that I don't like to see excretion of metals. I want them out. I don't want them in the system. But also, the first thing I'm thinking of when I'm seeing cadmium across the board, when I haven't done anything to trigger it, is do we have Helicobacter as an issue? And we look at this individual, and now we've got bismuth across the page, and we're not adding any peptimycin. And look at how much we need carnitine here. So these are strong indicators that Helicobacter may be an issue. And again, continued cadmium excretion. Also taking a look at some of these sky-high DHPPAs, especially if you've run a CSA and you're not seeing any bacterial imbalances. Again, looking at bismuth, looking at that high need for carnitine. And here again, most of the amino acids are low, and arginine is standing out like a little bit of a sore thumb that it's not following the trend of the other amino acids. And so the arginine level is a little more subtle indicator, but if you're looking at 8 tests at once, and there's an indicator on every one of those 8 tests, you want to be thinking, is Helicobacter an issue? Again, imbalances on a CSA, but we're still seeing the dumping of bismuth. We're not seeing Helicobacter yet, but I don't always expect that if I still have imbalances on a CSA. Low gut pH is usually an indicator, and also when I'm seeing blood in the stool. When I see blood in the stool, I think Helicobacter or I think hemolytic E. coli.